Okay, we have here today another interesting integral from the UNSW Integration Bee from 2020. This was semifinal round 2, problem 2. We have the integral from 1 over pi to 1 over e, natural log of the floor of 1 over x dx. Okay, I thought this was pretty interesting just because so much of this is just going to be interpreting it and kind of understanding these unusual bounds and kind of looking at the graph. So what I wanted to do, and what usually helps with the floor function, is having a graph for it. And so what I have over here to the right, this here is just the graph of just 1 over x. And what I did is I just drew this within our bounds because the lower bound is 1 over pi and our upper bound is 1 over e. I also wanted to include a point in between, which is 1/3, which I think is going to be kind of a useful point. If I was going to break this into two integrals, I would break it on 1/3. So of course, just looking at 1 over x is pretty easy because for everything here, we just have to flip it and take the reciprocal. So at 1 over pi, this 1 over x is going to evaluate just to pi, which is around 3.14. 1/3 is just going to evaluate to 3 exactly. 1 over e is going to evaluate to just e, which is like 2.718. So it's pretty clear what our graph of 1 over x looks like, but what we really want is the floor of 1 over x. So let's just look at that in blue. We'll look at the floor of 1 over x. And what the floor does is just rounds us down to the next highest integer. So kind of starting here, if we consider that pi is like 3.14, and all these values up to 1/3, all these values are just above 3, what the floor is going to do is it's going to round us down to 3 in this region. And then on the other side of 1/3, we're going to be just below 3. Like right here, we're going to be like at 2.99, let's say. And then we're going to come all the way down to e, which is 2.718. But all of these values here, they're all between 2 and 3. So what the floor is going to do is it's going to round us down in this region all the way to 2 for everything here. So now this simplifies the graph quite a bit, but what we actually want, we don't really want the floor of 1 over x. We want to evaluate natural log of the floor of 1 over x. So let's just take a look at that graph right now. Okay, now we have here down to the bottom our graph of natural log, floor 1 over x. And there's really not too much to it really because we just took what we have here and we input it into natural log. So we're in this region, we were at 3 for everything. Now we're just, everything here is going to be natural log of 3. And then here this is 2, so everything here is going to be natural log of 2. So recently when I've done other videos like this, what I would do is put this back into an integral. We could split the integral on 1/3. And then here in the first, for the first integral, our value is going to be just ln of 3, which is a constant value. And here it's going to be ln 2. But on one of those other integrals, there was a comment from David Kravitz that we actually could skip the integral altogether and just calculate the area of this because it's such a nice curve. We can just calculate rectangles really. So I could just kind of draw this in and we could find these two areas. All we really need to do is find the area of this rectangle and the area of this rectangle and add them together. And that's going to be our solution. And of course, we know the height on each of these right here. This height of this first rectangle is just ln 3. And this height here is going to be natural log of 2. And so to calculate these two areas, we just need width times height and add it together for the two rectangles. So what I can do is for the first one, we'll just calculate this as natural log of 3. And now this base, this width here is going to be just 1/3 minus 1 over pi. And that's going to be the area for this rectangle. And then for the second one, we'll just add it. It's going to be natural log of 2. And we just need to calculate this width, which is going to be 1 over e minus 1/3. And you could try to simplify this, but this actually matches what they have in the answer key. So I'm just going to circle it and call it good. So there you have it, doing a whole integral without any integration, just calculating the area from the graph. Thanks everyone for watching. Have a good day.